The Dynamic Learning Maps Alternate Assessment System is a new assessment designed to more validly measure what students with significant cognitive disabilities know and can do. This presentation will provide an overview of the mathematical concept of fractions for students with significant cognitive disabilities who will complete the alternate assessment. This training is one in a series of training videos that supports teachers of students with significant cognitive disabilities in their efforts to teach and assess. Sponsored by a grant from the U.S. Department of Education, Office of Special Education Programs, this training is part of the professional development efforts of the Dynamic Learning Maps Alternate Assessment Consortium. This module is the first of two modules on fractions. It will provide the participant with an overview of the instructional concepts that lead to a foundational understanding of fractions. Please note that it's important to view both fraction modules to address this area of the essential elements. Loosely speaking, a fraction describes a quantity that cannot be represented by a whole number. Consider the following question. Can you eat a whole cake? If your answer was no, then how many cakes can you eat? The answer wouldn't be one because you can eat part of the cake, just not the whole cake. But your answer wouldn't be zero either, because that would mean you couldn't eat any of the cake. So that leaves us with needing a different kind of number. A fraction describes the relationship between parts and wholes, when a whole is partitioned into equal parts. So maybe you could eat 1/10 or 1/8 of a cake. The denominator tells us how many equal parts into which a whole is divided, and the numerator tells us how many equal parts are in the fractional quantity. Students' fraction understanding should be built on equal partitioning, recognizing numerator and denominator, and part-whole relationships. Fractions tend to be a challenge for students, but we can mitigate some of those challenges by helping students create a strong foundation for fractional concepts. The big ideas presented here will help teachers focus on the larger concepts rather than isolated skills or individual concepts when planning for instruction. The first big idea is that fractions are numbers. Often, fractions are presented as if they were something separate and apart from numbers, but in actuality, they indicate a quantity and can be compared with other quantities. Next, students can think about fractions in two ways. Partitioning, which can be described as dividing or splitting an object into two or more parts, or dividing a set or an amount into two or more distinct subsets. And iterating, which is physically or mentally creating copies of a piece or unit fraction and counting how many make a whole. For example, in the fraction 3/2, 1/2 of the unit is repeated 3 times. This will be discussed again later in this module. The third and fourth big ideas indicate that fractions represent equal-sized portions or equal shares of a whole, and their names tell how many parts of the same size are needed to make a whole. The last big idea is that the more parts you use to make a whole, which is the number represented by the denominator, the smaller the parts will be for that same whole. Equal sharing is another way of showing the meaning of fractions. It's a really good place to start because students already have experience with sharing things with brothers, sisters, friends, and so on. When students share a set of markers, unit blocks, or even a snack, meaningful connections can be made with early fraction concepts that build on these experiences. Equal sharing situations should use both continuous and discrete quantities. Using clay is a good example of continuous quantity. It can be cut into as many equal shares as we need, whereas discrete quantities refer to a set number of items. For example, there are 12 chairs and 4 tables. If we want the same number of chairs around each table, how many chairs will be placed around the table? Discrete objects cannot be cut into smaller parts. So if we were to have 14 chairs and 4 tables, 2 chairs would not be used because we cannot divide them into equal shares. Pause for activity 1. One of the most commonly used meanings of fractions is the part-whole relationship. Shading the part of the whole that has been partitioned into equal parts typically represents part-whole fractions. For example, shading 3/4 of a rug, or dividing a piece of paper in half and shading 1/2. But there are other ways to represent part-whole as well. For example, during the lunch count, showing that 1/3 of the class is going to buy their lunch and 2/3 of the class brought their lunch. Or using measurement, the library is halfway to the office. Although the part-whole meaning of fractions is an important foundation for understanding fractions and rational numbers, it should not be the only way fractions are represented. Equal sharing is actually a better place to start instruction on fractions. One of the most important ideas for students to develop about fractions is that fractions are numbers, quantities that have values. The two terms associated with making the connections between fractions and whole number concepts is equal partitioning and iterating, which is counting a repeated amount. On this slide, we are demonstrating equal partitioning, the splitting or cutting of a quantity into equal parts. Students engage in equal partitioning when they split a set or an object into equal parts. Connecting this informal knowledge to fair sharing and then to more formal fraction concepts is key to providing effective initial fraction instruction. Using real-life story problems is the primary method for facilitating children's fraction learning. For example, we have 3 students in our group, and we have 2 pieces of clay. How much will each child get? Students can explore cutting the clay into as many equal-sized pieces as they wish, and then try to share the clay equally. When they answer the question, how much will each child get, the idea that fractions are numbers will be reinforced. In this example, the teacher might say, you cut each piece into 3 parts. How many parts do you have altogether? The student can count the parts, or the group can count the parts together. Again, the teacher might say, there are 6 parts. Now let's give everyone in the group an equal share, or the same amount of clay. After a student divides up the pieces, the teacher will then ask, how many pieces did each person get? To develop a comprehensive understanding of fractions, students need experience partitioning shapes or area models, as well as links and sets of objects. In whole number learning, students learn to count objects with one-to-one correspondence, 1, 2, 3, 4. The same is true for counting fractional parts. Each fractional part is counted in sequence to see how many multiple equal parts make a whole. Students can use their knowledge of more, less, or same to compare fractional parts to the whole. For example, give each student a collection of fractional parts. All the parts should be the same size, and tell them the kind of fractional part they have. In other words, half, fourth, or thirds as examples. Also, give them a sample of a whole. This can be done on an interactive board, felt board, or piece of paper. The task is to decide whether the collection is less than one whole, equal to one whole, or more than one whole. The student can count how many fractional parts they have in their collection. Then either the student or the teacher can use the fractional words to describe the collection. For example, the student might indicate they have 1 in their collection when comparing it to the whole. The teacher or student may say, 5 parts makes a whole. We have 1 part, or 1/5 of the whole. To develop a comprehensive understanding of fractions, students need experience iterating using area and length models. Pause for Activity 2. There's a substantial amount of evidence that suggests that effective use of physical models in fraction tasks is important to developing early fractional knowledge. There are 3 types of models that can and should be used when working with fractions. Circular fraction pieces are the most commonly used area model because it emphasizes the whole part concept of fractions, the relative size of a part as compared to the whole. However, there are other types of area models, including pattern blocks, geoboards, color tiles, and fraction bars. Regions such as rectangles can also be used to demonstrate how different shapes can represent the whole. The area model falls into a category of a continuous quantity. Note that even though circles are the most commonly used area models, they are also the hardest for students to create equal shares independently. Length models compare a unit of length to the whole length. We can cut a length into as many equal share pieces or units as we want. Again, this represents continuous quantities. Examples of length models include fraction strips, paper strips, Cuisenaire rods, and line segments. Number line models can also be useful in fraction instruction because they emphasize the idea that a fraction represents a quantity. However, it is not recommended that number lines be used until the student understands how to use a number line with whole numbers. The last model is the set model. In this model, a set of individual objects is perceived as a whole or a unit, and a subset of objects makes up the fractional part of the whole. For example, blue counters are 1/2 of a set of 12 counters. Using this model can be challenging for students. First, it's hard for them to think about a set of objects as a whole or unit. To help students see the set of objects as a whole, put a loop of yarn around the set, then create subsets still within the loop of yarn. Another challenge with set models is that students may focus on the size of the subset rather than the number of equal size subsets in the whole. For example, if 12 counters make up a whole, and a subset of 4 counters is 1/3, not 1/4, because 3 equal size subsets make the whole. Using discrete objects like colored counters may make it easier for students to see the subsets. We have discussed that partitioning and iterating are ways of helping students understand that fractions are numbers, and within these concepts, the students are able to understand the fractional parts are equal sized portions or equal shares of the whole or unit. Teachers will want to be sure to model fractional names regularly and gradually turn over the responsibility of naming the fraction to the student, but wait to introduce the fractional symbol until the student has some understanding of the words. The last big idea, the more parts used to make a whole, the smaller the parts, can best be taught exploring continuous quantity models so that students can partition objects into as many equal shares as they need. In Part 2 of the Fractional Concepts and Models, we will discuss the essential elements and instructional practices for students with significant cognitive disabilities. Thank you for participating in the Fraction Part 1 module. For further information, please go to www.dynamiclearningmaps.org.